Hello everybody, this is Mr. Yosef. I hope you're doing okay today. Today we're going to be factoring a polynomial, and sometimes there are polynomials in a certain form that have a certain that have a certain pattern. So if you look today, we're going to look at the difference of cubes and the sum of cubes. And whenever we have a polynomial that is presented in either of those forms, we are able to factor it in this way. And you will see that if it's a difference of cubes, your answer will look like this. If it's a sum of cubes, your answer will look like that. So our first goal is we need to look at what we have in front of us, and we need to ask ourselves, is this function in the form a cubed plus b cubed? Okay, that's the first question you're going to have to ask yourself, and you have to be really careful, because if you look at this 27 is by itself. It doesn't have a cubed. So in the formula, it's a cubed. And if we want to be more intentional, we can also just put parentheses around it like this. So here, we don't have a single unit that's being cubed. However, we can rewrite this to do that. So what you need to think about here is, what three same terms multiply to give me 27x to the third power? So I hope you notice that 27 is the same thing as 3 to the power of 3. So I could technically write this 3x cubed plus, and then what same three numbers multiplied to 8? That would be 2. And if you don't believe me, you can just do 3x times 3x times 3x, and you will see that you get 27x cubed. If you do 2 times 2 times 2, you see you get 8. So this form now looks the same as a cubed plus b cubed. So this term right here is our a, and this term right here is our b. I'm going to go ahead and erase this so we can keep it clean. So now what we're going to do is we're just going to plug everything into our formula. So f of x equals a plus b, a squared minus ab plus b squared. I'm just writing it again, and then I'm going to substitute everything. So I have 3x plus 2 parentheses. Watch what I'm going to do here. I'm going to put a parentheses for a, because my a is 3x, and that's being squared, minus 3x times 2 plus 2 to the second power. So I'm just being really extra here, because when I say something is being squared, I'm taking whatever term I have and actually doing it twice. So we should have 3x plus 2 parentheses 9x squared minus 6x plus 4. Now once again, if you do not believe that 3x squared is 9 squared, you can always write 3x times 3x, which you will see is 9x squared. So if I told you to factor it, you would just get a box and box it, and you would be finished. This is factored. But if we go back to instructions, it says factor, check, and it says find the roots. So to find the roots, we're substituting 0 for f of x, and we're going to have to set each factor equal to 0. So we're going to do the first one, which is just 3x plus 2 equals 0. Subtract 2, get negative 2, divide 3, and get negative 2/3. So that is our first term. We should be familiar with finding a zero, a root, a solution of something that looks like that. So next is the lovely 9x squared minus 6x plus 4 equals 0. For the sake of this video, I'm not going to go through the process of actually trying to factor this. Because if you try to do guess and check and you're like, oh, let me do this. Oh, that should be 3x and 3x, and that's minus 2 and minus 2. And if you checked your work, you would see that it wouldn't work. So we're not going to go through that process, because anytime you use a sum or difference of cubes, 99% of the time, this term right here will not be factorable. So that means we need to use the quadratic formula. And the quadratic formula is giving us our zeros. So I'm going to write the quadratic formula, which I know we all have memorized. And before we even do the quadratic formula, I'm going to go to the side of my paper and I'm going to label everything that's A, B, or C. So remember that a quadratic is ax squared plus bx plus c. These are where you're getting the letters from. So if we look at our example, we have a 9, we have a negative 6, and we have a 4. So a equals 9, b equals negative 6, and c equals 4. All I have to do is substitute everything in. And I know it is nice and tedious. It is also really easy to copy something down incorrectly. So we just double check real quick. Our B's is negative 6. Okay, I substituted that. My A is 9 and my C is 4. So everything looks good. So next I'm going to simplify. I hope that you notice that this negative and negative is going to give you a positive. So we should have 6 plus or minus the square root of negative 6 squared means negative 6 times negative 6, which is 36, minus, then I'm going to multiply all these lovely numbers. So 36 times 4, so I can try to do this in my head, or you can just write it down, just to be safe, and you'll see that you get 144 over 18. I keep going and I simplify what's inside. 36 minus 144, I know I'm going to get a negative number. And if I do this, I know I'm going to get an 8, 0, and 1. So I should get 108. Once again, it's not hard to check. You can do 108 plus 36 to see if you get 144. And you do. And then all this is over 18. Something that we need to remember is you can never take the square root of a negative number. Like, you won't get a real number. So we invented something called imaginary numbers. And the one thing that you need to know about imaginary numbers is the fact that negative 1 equals I. So just remember that the square root of negative 1 equals I. That's just something that you have to remember. So keep that in mind. So when I continue this problem, I get x equals 6 plus or minus negative 1 times, this is where you have to think. We need to break down 108, and we need to include perfect squares. A perfect square is a number like 36, because 6 times 6 gives you 36. You're able to take the square root. So you would just mess with your calculator, see if 108 is divisible by 4, which is it is. But I believe that 108 is also divisible by 36. I think 36 times 3 will give you 108. And once again, you can use a calculator just to make sure, and it is true. And then I divide everything by 18. Then now I'm going to take the square root of stuff that I can. So the square root of 36, first of all, is 6. So I take a 6 outside. The square root of -1 is I, because that's how we defined it. And we still have the square root of 3, because we didn't do anything with the 3. And we divide this by 18. Normally, this would be your answer, and you can call it a day. But we see that there's some numbers that can be divisible. So I don't know if you noticed that this 6, 18, and 6, they're all divisible by 6. So I'm going to show you how to write it in a simpler way so you never get this wrong. So you can actually split them up like this, and then divide these two by 6, and you get 1/3 plus or minus, divide these two, and you also get 1/3 I square root of 3. Just notice that the I and the square root of 3 did not move. Also notice I didn't do 3 divided by 18. You can't do that because the 3 is in the square root. So this is the lazy way to write it. Or if you want to show me that there's two solutions, which there are, you can write 1/3 plus 1/3 I square root of 3. That's answer number 2. And then the other one is answer 1/3 minus 1/3 I square root of 3. Box that. That's answer number 3. If you're asking me why am I doing answer number 2, answer number 3, because don't forget about answer number 1. So the roots for this question is -2/3, 1/3 plus 1/3 I to square root of 3, and 1/3 minus 1/3 I to square root of 3. Thank you.